right, this is the forces video. So the first thing we learn about is a quantity. Now, a quantity is any measured amount. So anything you measure is a quantity. Now, there are two types of quantities. The first type is a scalar. And scalars are quantities with just size or magnitude associated with them. So the basic type of scalar quantities are volume, speed, mass, area, length, time, temperature, and height. And these can be added, subtracted, multiplied, divided with no other consideration. Now, the second type of quantity is known as a vector quantity. And a vector has both a magnitude and a direction. Now, different examples of vectors are velocity, acceleration, force, weight, and displacement. Now, let's ask this question. If people are not racing side by side or at the same time, how can it be determined who is faster? Now, we can use something called a rate. So if you look at everything off to the right, everything of those like beats per minute, babies per lifetime, gallons per second, miles per hour, they're all rates, something per unit of time. Rates are all ratios of a quantity per time. Now, in the classes, we did a competition to see who could eat saltines the fastest. So you can see here that we could find the rate of saltines per minute and compare and see who can eat saltines faster. So now what does it mean to say someone or something is fast? So let's talk about speed. So speed is a rate. It's a ratio with time. Now, speed is a measure of how fast distance is covered. So speed is measured in a distance unit divided by a time unit. Now, some common units for speed are meters per second, which is the most common used in science, kilometers per hour, miles per hour. So if you look at all of these examples, right, all of them are rates because there are some quantity per time, the ratio of quantity per time, but not all of them are speeds. So you'll see here that these only speeds are going to be like miles per hour, light years per year, centimeters per century, meters per second, because those are all distances per unit of time, right? So all speeds are rates, but not all rates are speeds. So we did that wind up toy lab in which you were asked to calculate how fast the wind up toys were going on the table. Now the first part was just finding the resolution and uncertainty digit in the measuring instruments, and also looking at the rules for significant figures when multiplying and dividing. Now, notice that record everything that you can. So if you look at the distances and the times that were covered, you always record the uh, resolution and that uncertainty digit. All right. So, what is the difference between instantaneous speed and average speed? So, instantaneous speed is the speed at any moment or instant in time. So we need either a radar gun or a speedometer to measure an object's instantaneous speed. That'll give you that speed at that exact moment. So radar guns, well, they work by comparing the frequency of the original sound wave to that returning sound wave. And depending on how condensed that wave is, what it's going to do is it will be able to tell you how fast that car is moving. All right, so average speed. Anytime you use a stopwatch to measure speed, you are measuring the time interval and thus not an instantaneous speed. Average speed occurs over a time interval, and it is determined by using a stopwatch and a measuring stick. So we measure the given distance and then determine how much time it takes for an object to travel that distance. Now, all speeds that are going to be measured in this class are going to be some average speed. So we did the lab walk the walk in which we were measuring the average speed. So first, always resolution, uncertainty digit, and significant figures. Now, then, scientific claim. So, is this a scientific claim? Now, skipping is faster than any motion where one foot is always on the ground, and make a hypothesis. So, these are all reviews from the last section. So, then we used a stopwatch to measure the tape in the hallway. We went outside or in the hallway to see how far you can go doing these different actions, walking, backwards walking, speed walking, or skipping in 10 seconds. Then you turned around and timed how long it took to do these actions going 20 meters. Now, then we did that experiment. You were supposed to identify the independent variable, the dependent variable, three constant variables, and talking about hypothesis. And if you look at this, notice that even you always record that the resolution and the uncertainty digit, right? And that answer when you're dividing can only be as accurate as the least significant figure. Always least significant or least significant figures, right? So It just so happens that both measurements have four significant figures. Your answer can have four significant figures. Everything after that, you don't know. All right, so keep in mind with instantaneous versus average speed, all of these were average speeds because we weren't using a radar gun, we weren't using a speedometer, we were measuring a time interval, and that is the average speed over that time interval. And then we talk about frame of reference, random errors, and systematic errors. And the last part is to look at the speed at which someone skips and calculate how long it would take them to skip a mile. All right, and as always, there's just too much unknown in the universe to take a break from learning. Get out there and question everything.